Our final project is a robotic cat toy that's inspired by a Roomba. We all have spent lots of time living or playing with cats, but sometimes you don't have the time to entertain them, and they can get sad or bored. Our final project aims to address this problem by having a completely user-free cat toy that can keep cats entertained without any effort. When turned on, the robot moves forward in a straight line, encouraging the cat to chase it. What makes this robot unique is that it has a strategy for detecting collision directions, which allows it to turn away from an obstacle. Once the robot has been caught, it drops a treat for the cat, which is a method of positive reinforcement encouraging playing with the robot as well as benefiting the cat's mood. Our state transition model has 5 states. When it's asleep, it goes into the moving state when the joystick is bumped or pressed. From here, it goes into either the turning state when it detects a collision or a bored state when it hasn't been caught. In any of these states, it can be caught by pressing the button on the joystick, in which case it goes to the cooling down state, where it doesn't move.
Our project is built on a custom wood chassis with several 3D printed mounts to hold everything together. To drive, we use 2 generic hobby motors and a DRV8833 motor controller, along with 4 AAA batteries mounted right here. We also use a servo motor included in the lab kit in order to power a treat dispenser here that would open underneath to dispense the treat. We use the IMU mounted right here for determining movement direction. We're of course using the ESP32 and battery from the kit, as well as 2 small breadboards and soldering to make wiring easier. On the bottom, we have a speaker and a little caster wheel purchased from Amazon. Lastly, most of our sensing is done using a joystick sensor that attaches to our 3D printed dome right here. A hardware subsystem that we are proud of is our use of a joystick as our main sensing device. The joystick has 2 axes of direction, X and Y, as well as a button allowing for us to have a full range of sensing. The way it works is the joystick is connected inside, this is a different joystick, so that when the dome is on top, it can sense which direction it's getting pushed from. For our catch mechanism, for when the cat catches the robot, it presses down on the button and it's a digital input so that it knows that it's been caught.